Dear students, Assalamu alaikum. How are you all? I hope you all will be fine. Dear students, today we will discuss about numerical problems of chapter number 5. So, first numerical 5.1 is find the gravitational force of attraction between two spheres, each of mass 1000 kilogram. The distance between the centers of the spheres is zero point 0.5 meter. Dear students, both masses m1 and m2 are equal, so m1 is equal to m2 is equal to 1000 kilogram, right? Distance between their centers is equal to d is equal to 0.5 meter, and we need to find the force between the spheres, that is F. So we use the formula F is equal to g m1 m2 divided by d square. So after substitute the values of the gravitational constant g, m1, m2 and d, we get the result, that is F is equal to 2.67 multiplied by 10 raised to power minus 4 Newton. So our result is gravitational force between the spheres is equal to 2.67 multiplied 10 raised to power minus 4 Newton. ये स्टूडेंट्स, ये न्यूमेरिकल 5.1 था जो हमारा सॉल्व हो चुका है. अब हम 5.2 की तरफ बढ़ते हैं. The gravitational force between two identical lead spheres kept at 1 meter apart is 0.006673 Newton. Find their masses. Dear students, both masses are equal, so m1 is equal to m2. So we can substitute in place of m1 m2, or in place of m2 we can substitute m1. So gravitational force between the masses is 0.006673 Newton, and the distance between their centers r is equal to 1 meter. You can write rd. Gravitational constant is equal to 6.67 multiplied 10 raised to power minus 11 Newton meter square per kilogram square, and we need to find m1 and m2. We use the formula F is equal to g m1 multiply m2 divided by r square. You can use d in place of r. So m1 multiply m2 is equal to F multiply r square divided by g. So after putting the values, we get the value of m1 multiply m2 is equal to 1.00 multiplied 10 raised to power 8. So we put m1 in place of m2, so it will become m1 square, that is equal to 1 multiplied 10 raised to power 8. So m1 is equal to 1 multiplied 10 raised to power 4 kilogram, and also m2 is equal to 1 multiplied by 10 raised to power 4 kilogram. So result, mass of each lead sphere is equal to m1 is equal to m2 is equal to 1 multiplied by 10 raised to power 4 kilogram. So now we discuss numerical 5.3. Find the acceleration due to gravity on the surface of the Mars. The mass of Mars is 6.42 multiplied 10 raised to power 23 kilogram, and its radius is 3370 kilometer. So data that is given is mass of Mars is 6.42 multiplied 10 raised to power 23 kilogram, and radius of Mars is 3370 kilometer, that is equal to 3370 multiplied 10 raised to power 3 meter, and write in standard form 3.37 multiplied 10 raised to power 6 meter. We need to calculate gravitational acceleration g at the surface of Mars. So we use the formula g is equal to gm over r square to calculate the value of g. So after putting the values of g, m and r, we get the relation as. So our final result will become g is equal to 3.77 meter per second square. So result is gravitational acceleration is equal to g is equal to 3.77 meter per second per second. So dear students, now we discuss about numerical 5.4. The acceleration due to gravity on the surface of moon is 1.62 meter per second per second. The radius of moon is 1740 kilometer. Find the mass of moon. So dear students, the data that is given, Gravitational acceleration on the surface of moon is 1.62 meter per second and radius of moon is equal to 1740 kilometer, that is converted into meter, and it will be equal to 1.74 multiplied 10 raised to power 6 meters. So the value of gravitational constant is equal to 6.67 multiplied 10 raised to power minus 11 Newton meter square per kilogram square. We need to calculate the mass of the moon. So we use the formula m is equal to gr square over capital G. So after putting the values, we get the relation m is equal to 4.90 multiplied by 10 raised to power 12 divided by 6.67 multiplied by 10 raised to power minus 11. So minus 11 will be added when it goes on the numerator. So final value of mass will become m is equal to 0.735 multiplied 10 raised to power 23, and right in standard form we get the value of mass, that is equal to 7.35 multiplied 10 raised to power 22 kilogram. So result, mass of moon m is equal to 7.35 multiplied 10 raised to power 22 kilogram. So dear students, now we discuss numericals 5.5. Calculate the value of g at a height of 3600 km above the surface of earth. So the data that is given, height above the surface of earth denoted by h is equal to 3600 km. After converting into meter, we get 3.6 multiplied 10 raised to power 6 meters. The value of gravitational constant g is equal to 6.67 multiplied 10 raised to power minus 11 Newton meter square per kilogram square. And the mass of earth, that is constant, is equal to 6 multiplied 10 raised to power 24 kilogram. We need to calculate gravitational acceleration g at a height h above the surface of earth. So we use the formula g is equal to gm divided by r plus h whole square. After putting the values, we get the relation g is equal to 6.67 multiplied 10 raised to power minus 11 multiply value of mass 6 multiplied 10 raised to power 24, and substituting the values of r and h, we get the value of g finally 4 meter per second. So our result is gravitational acceleration is equal to g is equal to 4 meter per second. Dear students, now we discuss numerical 5.6. Find the value of g due to earth at geostationary satellite. The radius of the geostationary orbit is 48,700 km. Radius of geostationary satellite is equal to r is equal to 48,700 km. After converting it into meters, we get 4.87 multiplied 10 raised to power 7 meters. Mass of earth is equal to 6 multiplied 10 raised to power 24 kilogram, and gravitational constant g is equal to 6.67 multiplied 10 raised to power minus 11 Newton meter square per kilogram square. We need to calculate g at h. So as we know that g is equal to gm over r square, by putting the values, g is equal to 6.67 multiplied 10 raised to power minus 11 multiplied 6.10 raised to power 24 divided by 4.87 multiplied 10 raised to power 7 whole square. After simplifying, we get finally value of g, that is equal to 0.17 meter per second, and result is gravitational acceleration is equal to 0.17 meter per second. So now we discuss numerical 5.7. The value of g is 4 meter per second at a distance of 10,000 km from the center of earth. Find the mass of the earth. So given data is gh is equal to 4 meter per second and distance from the earth is equal to r plus h, that is equal to 10,000 km. R plus h we use because it is the distance from the center of earth. So after converting it into meters, we get 1 multiplied 10 raised to power 7 meter. Value of gravitational constant g is equal to 6.67 multiplied 10 raised to power minus 11 Newton meter square per kilogram square. We need to calculate mass of earth, so we use the formula GH is equal to GME over R plus H square, and by putting the values we have ME is equal to GH into R plus H square over G. Simplifying the formula we get, and putting the values we get ME is equal to 6 multiplied 10 raised to power 24 kilogram. So our result is mass of earth is equal to 6 multiplied 10 raised to power 24 kilogram. So dear students, now we discuss numerical 5.8, and it is important numerical. At what altitude the value of G would become 1/4 than on the surface of the earth? Dear students, value of G on the surface of earth is 10 meter per second, and the height H, the value of G is equal to 1/4 of the value of the earth, that is G over 4, that is equal to 0.25 meter per second. So value of gravitational constant G is equal to 6.67 multiplied 10 raised to power minus 11 Newton meter square per kilogram square, and we need to calculate the height of the satellite. So there is no need to put the values of the constants and in the formula. We only want to calculate the height H, and without putting the values we get the result. As we know that G at H is equal to GME over R plus H square. So putting the value of G at H, that is equal to G over 4, is equal to GME over R plus H square. We know that mass of earth is equal to GR square over G. So G is multiplied with the mass of earth, that is GME is equal to GR square. Putting the value of GME in above equation, we get G over 4 is equal to GR square divided by R plus H whole square. So G is cancelled with the G, and we get 1/4 is equal to R square divided by R plus H whole square. So cross multiplication, after we get R plus H whole square is equal to 4R square. Taking square root on both sides, we get R plus H is equal to 2R. We need to calculate H, so this R will be subtracted on the other side. So we get final result H is equal to R. So our result is altitude is equal to 1 Earth's radius. Next we discuss numerical 5.9. A polar satellite is launched at 850 km above Earth. Find its orbital speed. So height of the satellite above the surface of earth is equal to 850 km. After converting it into meters, we get 8.5 multiplied 10 raised to power 5 meters. We know that mass of earth is equal to 6 multiplied 10 raised to power 24 kilogram, and value of gravitational constant is equal to 6.673 multiplied 10 raised to power minus 11 Newton meter square per kilogram square. We need to calculate the orbital velocity V0. So we use formula V0 is equal to under root G at H into R plus H. Putting the values, so first we put the value of G at H. So V0 is equal to GME over R plus H square. So R plus H is cancelled with the square. So only one R plus H is left in the denominator. So we get finally formula V0 is equal to under root GME over R plus H. So after putting the values, we get the value of orbital velocity 7431 meter per second. So our result orbital satellite speed of satellite is equal to V0 is equal to 7431 meter per second. So 5.10 numerical. A communication satellite is launched at 42,000 km above Earth. Find its orbital speed. It's like that 5.9. Height of satellite is equal to H is equal to 42,000 km. So after converting it into meters, we get 4.2 multiplied 10 raised to power 7 meters. Mass of earth is equal to 6 multiplied 10 raised to power 24 kilogram, and gravitational constant G is equal to 6.673 multiplied 10 raised to power minus 11 Newton meter square per kilogram square. We need to calculate orbital velocity. We finally get the formula like numerical 5.9. V0 is equal to under root GME over R plus H. After putting the values, we get finally speed of satellite V naught is equal to 2876 meter per second. So our result is orbital speed of satellite is equal to V naught is equal to 2876 meter per second. Okay, dear students, you will practice these numericals at home. Thank you so much. Allah Hafiz.